Okay. Okay. All right. Okay, let's see here. We have excellent stream health. Okay, let's see here. We have excellent stream health. Okay, let's see here. We have excellent stream health. Slight delay, that's fine. Alrighty. All right, perfect. I know that there is a slight delay here on this stream, so let's assume that it takes 3 or 5 seconds for the stream to start, and then we'll get started. So that's 5, 4, 3, 2, 1. That's my measurement of time, okay? Don't worry. All right, so hello everyone. What I have today is I have a Gantry system that I'm getting ready to ship out. Hey Alexandru, nice seeing you here. It's late for you. It's interesting to see you here. Thank you for tuning in. Let me lower the volume here. So anyways, what I have today is a Gantry system that I'm preparing to ship out to one of our distributors in Texas, actually. And they're going to be using it to build a little display for a training that they have coming up. And you know, I thought I have it here, I have it hooked up, I have the controller hooked up, I have CODESYS running on my PC. Why don't we just you know, show the people on LinkedIn what we can do with this Gantry system, or what it is, right? I hear a lot of talk about, you know, 6-axis robots and collaborative robots and all of that. I guess we gotta remember that every solution has a place for each application, right? Like, not everything, you wouldn't solve everything with a hammer. So today I'm going to show you this, and I am monitoring, or I'll try to keep monitoring the chat here. So if you have any questions or any comments, you want me to do something while I'm live, let me know and I'll do it. All right, so let me switch over to this other view so I can stand up and show you what I have here. So I'm going to go over here and I'm going to show you what I have. I'm going to have to ask for your forgiveness because, yes, this is not the beautiful setting that you will see, or the most beautiful setting that you will see. Yes, I have some clamps here, but keep in mind that this is my office and I'm just setting this up quickly here. So what we have here is we have an H gantry. Okay. So this is an H gantry, and basically what this does is that this is the carriage, and it'll move along all of the surface, right? What's the beauty of this is that this is self-contained, right? So if you build a machine to manipulate something along or in this area, you would only need to build a machine around this gantry. Unlike a robot where you have to secure all of the area around the robot depending on the reach of the robot, with this is self-contained. So everything will fall into this area. Now you can also see here, what else do I have? This is another axis. This is going to be the Z-axis that's going to be mounted here. So the nice thing is that this bracket, the mounting pattern for this bracket actually matches this portion here. So this is the Z-axis, ball screw actuator. It has some nice guides there, or guiding there. The motor is back here. This is an integrated motor. So this is the motor, a stepper drive motor, and the drive is actually embedded in here. That's where you can see the connections that I have there. So I have two motors, and I think you can see them there on the video. I have two motors. Both of these motors are going to be driving the X and Y, and then this motor is going to be driving the Z axis. What else do I have? I have a power supply, nothing fancy there, just a power supply that I'm using to power up the motors and this motion controller, or this PLC, right? This PLC has the connections for the motors on the side. I also have, it's an EtherCAT master. I can connect some other things, like it has some onboard I/O as well, and I can do like some other thing like RS-232. I can do I/O link. I can do a bunch of other stuff. It has two USB ports and whatnot. Anyways, that's kind of like an explanation of what this is. This gantry, I like it a lot because it's very interesting the way that it works. You can look it up later. It's called EXEM, and basically it is a single continuous belt that goes around the whole gantry, and it's actually attached, or it's fixed on the carriage. But with this continuous belt, what you have is that by moving both motors, you accomplish a linear move this way or a linear move this way. If I was to move only one motor at a time, let's say I only move this motor and this motor is stopped, then the movement will be diagonal, okay? Actually, I'm going to leave it open so you can see. I don't know how clear you can see the tooth belt there, but let me jump back over here. And I mentioned that I was going to be monitoring the chat, so let me come back here and see if we have anything going. I don't see any comments here. I saw a comment earlier, but for whatever reason the comments are not showing up here. Okay, let's keep going. So let's jump into CODESYS. And in CODESYS, this is CODESYS, and what I have here is I have a version of CODESYS, which is version 3.5, Service Pack 12, patch 6. This is an older version of CODESYS. There's, I think right now they're in version like 15, Service Pack 15 patch, I don't know what, but it's newer definitely. Doesn't matter, this is going to serve the purpose for today. So I'm going to open the project that we want to work on. By the way, this project that I'm opening, you can also get it from here. So if you go to festo.us, okay, let's give that a second. I don't know if I typed this in correctly. Oh, sorry, I'm using something. Festo, let me open it on my other screen. Festo.us. There we go. If you go to festo.us and then you type in Festo positioning basic library, you're going to find it under support and downloads. And then, let me see here, support and downloads, and it's going to be under software. And here it is, function blocks CODESYS. This is the library that I'm going to be showing you today. It includes all of these functions like system configuration, homing, jogging, moving point to point, even CNC movements and so on. So you can download it directly from here. It's fully, free to download. You can just get it directly from the Festo website. All right, so let's close this, close that. So this is the project. Like if you open that project, this is what you're gonna see. Actually, it's driving me crazy that I see myself flip there. So let's flip it like this way. There we go. So now when I turn to my monitor, it'll look like I'm looking at the software. Okay. So this is the project that you downloaded from the Festo website, and this project already includes the library itself, it already includes all of the motors configured for that little gantry system that I showed you. If I go to the POUs, you have, for example, this global variable list for configuration. And let me make this bigger. I don't know if you can see it there on the screen that we're using today. So this looks maybe overwhelming to people, but don't worry about it. This is just the parameters that you can configure directly on a web visualization that I'm going to show later in just a few minutes. So you have here like how many motors or how many drives are you going to be using on this system? Because right now I only have 3, X, Y, and Z. But I could also add like a theta drive for a rotary, right? I could have that. I could have another axis for, you know, maybe I had an additional auxiliary axis on the side or something. So I could have up to 6 axes being driven directly from here. Okay, so the first thing that we have to do is we have to communicate to this PLC. So I'm going to double click on the device, and then I have a gateway running here. So this is the PLC. How did I find, you know, you can double click on it if you're connected on the same network and it'll find it. If I didn't find it for whatever reason, I can also open a little software. Actually, you can do it, I believe, from here. Online, yeah. Scan Festo devices. So if you scan the Festo devices, it should find, you can see, should find that device, the name of the device, and the IP address, right? In this case, 192.168.4.2. We don't have to worry about any of that because I already have my PC connected on the same range or on the same network and everything, so we should be fine. That's why we see it here. Now this is the current device connected, and now I'm gonna go online. Let me check the chat here. For whatever reason, I'm not, like, I see some notifications, but I don't see anything on the chat. I don't know what's going on. I'm sorry. I'm kind of new to this thing. Let's see. All right, so we're online, and the first thing that I notice is that I have a red triangle here on the z-axis. What am I missing? Oh, I know what I'm missing. So there is a problem with the z-axis, and we're going to confirm that in just a second. I'm going to go into here. There's a visualization. This is something really neat about CODESYS that I've seen a lot of people on LinkedIn talking about. I actually saw a post earlier from earlier this week or the week before from Tovi. She was saying that it's a really nice thing to have visualizations available on CODESYS, right? So here's an example. This is the visualization that you can use to commission this Gantry system. And this is CODESYS, but this visualization, you could also have it running as a web visualization. So on under the visualization manager, you can also add an instance of a web visualization. And now you should be able to access that web visualization through any web browser, like I have it here. The only thing that you would do, actually I can do it again for you. You would type in the IP address of the device. My case is 192.168.4.2. You access this splash screen. Let me check LinkedIn here. So I'm afraid that maybe it's not streaming correctly. While I'm checking this. Okay. So yeah, I was saying this is the splash screen, and then here you have a CODESYS tab that you can click, and then you can click on visualization. By clicking on visualization, you're going to go into this portion, which is the same visualization that we saw within the CODESYS environment. But now this is Edge. This is Microsoft Edge, okay? So within this visualization, what I can do is I can actually control the whole Gantry system. The first thing that you're going to, if this was, you know, if I was just booting this up right now, it would be in no mode, meaning that it's not doing anything. It's just in no mode, right? So the next thing that you have to do is go into configuration mode, and then here is where you would specify basic stuff like the strokes of your X and Y and Z axis, right? So for that, you have to log in, and you can check the login on the user manual for this. I'm going to log in. Actually, I'm logged in already. So if I was logged out, like now, I wouldn't have access to some of these options. So if I wanted to log in, I do the password, I do log in, and then I'm logged in now. So now what I can do is I can load a parameter file, which I created previously. Remember, this is not I'm not going to do a 5-hour video on how to do this thing, maybe later if there's enough interest. But for now, I'm just going to load a file that I already created before. What is that file? That file basically is, if I was to go in here and adjust all of these values here, I could, adjust everything according to my system and then go back to settings and save this parameter file. Now, this parameter file resides on the PLC or in the motion controller, and then later on, I could just, maybe copy and paste to several other, if I'm doing 10 machines that have this same system, I could just grab this file and put it on every single PLC or motion controller and get it over with, right? But today we're lucky because it's just one system that we have to configure. So I already have the strokes punched in here. These are the software limits. So if I recall my system, as I can see here, it's on X, I have 430 millimeters, 260 on Y, and then 100 millimeters on Z. The drives, you can specify how many axes you have or you want to have enabled. In this case, I have X, Y, and Z. You can also specify if you want to limit the axis. So if you want to limit the velocity, acceleration, deceleration, you could do that from here. In this case, I don't have any limits. And then you can specify the homing. So actually this is interesting. The homing order of a gantry system. Usually you would do this. My motor 3 is my Z-axis. So whenever I execute a homing routine, what I want is that Z-axis to pull off from the surface, right? Because I don't want to start moving the X and Y, and if that Z-axis is too low, hit something on the X and Y plane, right? So what I'll do there is I'll pull up. So homing order, as you can see here, homing order. First, the Z-axis is going to pull up. Then the Y-axis is going to start moving home. And then the X-axis is going to start moving home. That's the way that I have it right now. Okay, enough of that. I'm guessing that a lot of people wants to see, what does this thing do, right? So let me switch to this view so you can see. So on this view, what we're going to see is both the hardware and the software. So right now, I'm already homed, as you can see here, so I'm not going to perform a home. But if you wanted to do a home, you will just go into this mode here, this operation mode, homing mode. You would enable the system. So now you can see, I don't know if you noticed, but this enabled signal is now on. So I'm going to disable it. You can see, enabled. Now it's enabled. And then I would execute a home from here. Right now I'm home, so there's no need for me to do that. But I could also jog the system from here, right? So let's say that I wanted to jog the Y-axis, positive. You see, now the Y-axis is moving, and I see some bits here. You see the busy bit and the is moving bit. Come on. The reason why I'm talking about these bits or these signals is because all of these signals are available to you as a user programmatically. So now you can go, it's actually I think it's a structure on CODESYS that you can access and see, okay, is my system moving? So it'll tell you, yes, it's moving. And then you can do all of your conditionals depending on this state, right? So that's the Y-axis. Now the X-axis, as you can see, and I can increase the speed on this thing. It's going too slow, 60 millimeters per second. So now it's going faster. And this is something that I like a lot, and I've had a lot of customers tell me this too. You notice that on the visualization, this animation is actually moving. This is something that I like a lot about this platform, that you can see, like, a lot of the times you might not be able to see clearly the system that is moving, like exactly, or maybe if you're visualizing or you have another person there monitoring for you, but you want to make sure that it's also moving. Like for instance, in my case, the system is, I don't know, like 5 meters away from me, so I can see it from here. Now, of course, this is not a dangerous, environment or anything. No one is going to get their hands pinched or anything like that. So that's why I can move it like this using the visualization. But I don't know. I think it's pretty cool. Now, remember that when we first started, I told you that there seems to be an issue with the Z-axis, right? Like if I go back to CODESYS, here, it looks like let me close this one. This motor, this third motor, it's showing us like an error or something. And if I go back to the web visualization over here, let me see, over here, you're gonna see that that if I move the z-axis like this, you see that it's moving on the, let me open my screen. You see that it is moving on the animation, but the hardware is not moving. I know why. Because we're simulating this axis. So we're not commanding it to move on the hardware. We're just commanding it to move on the software. This is perfect also for simulation, because what I could do is I could actually have my 3-axis simulated, and I could, you know, write all of my code without even having the hardware and see how it's going to move here on this little animation. That's really helpful for a lot of people that don't have access to the hardware yet, or maybe if you're just learning codices, you could do this too. All right, so what do I need to do to enable this axis? So I'm going to go back to CODESYS. I'm going to log out, actually. And under this device, actually this device 3, you have this option that's called virtual mode. So this is selected. And if we see the other axis, like for example the y-axis, these are not selected. So I'm going to deselect this virtual mode. So now CODESYS, or the motion controller, knows you do have actual hardware that you need to move, right? Or that I want you to move. So let's download this change into the motion controller. And I think now we're gonna have to home it again. So let me see. I don't know if I should reload the LinkedIn page, because for whatever reason, it seems like it's kind of stuck, and I don't know if you people are watching or not. If you're not watching for whatever reason, maybe you'll watch the recording, or you will shoot me a message, and maybe we can do this again. See here. Watching or not? Oh yeah, okay, I see it on my phone. Okay, so that's good. Now I can monitor my phone, and I can see if there are any comments or questions. All right, so the download is finished. And now you can see that after my download, my processor goes to stop, so it's not running anymore. I can, usually I use shortcuts on my keyboard, but now I'm gonna use this so you can watch. So you have this start button here on the top. I usually use this F5 shortcut, and that's what I'm gonna use. So F5. So now, look at that. Now this is green, and it's saying, okay, you have an actual physical motor that you're going to command. Perfect, that's what we wanted. So let's close all of that. We don't need it. We can, yeah, let's leave that going. All right, perfect. So I told you that, oh, thank you, Ronnie. Now I see your, and Kevin, now I see your comments. Okay, thank you so much for letting me know that it's working. So now I told you that the very first time that you download something like this, you're gonna have to go through these operation modes. And just as I'm doing it right now on the web visualization, you're gonna have to do it programmatically too at one point, whether it's via CODESYS, or if it's on Rockwell, or if it's in Siemens, whatever, right? Oh, because I forgot to mention, you can interface to this motion controller via Ethernet IP or Profinet. So you can use it as a lower device on those networks. So operation mode, I'm going to go to configuration mode. I'm going to log in here, putting in the password. I'm not going to say the password here because why? I guess it's public, but you can check it out on the user manual. So now I'm logged in. What I'm going to do is I'm going to change. Let's leave the order as it is. I'm going to load the parameter file. So now it says parameter loaded from file. And let's go to homing mode and enable the system. Right now it's not enabled, so I'm going to enable the system. And I can hear the motors, like the noise of the motors enabled now. And what I'm going to do now is I'm going to start the homing. Before I start the homing, let me go there, because since I have it on these clamps, I don't know if it's going to move a little bit. So you can see the small clamps that I have there are not the strongest clamps. So let me I'm going to go there. I'm going to execute the home and then just quickly go over there. So now it's moving. You see the z-axis is moving first, right? And then the y-axis, just as we had it. Just want to make sure, you see, that's what I was afraid of. That because I have these clamps, it's not the most robust setting to do this, but don't worry about it. I have control of this. Hope. All right, I'm back on the PC. So you saw the homing process. You saw that the z-axis homed first, then the y, and then both the x and y homed at the, and then the x homed at last. All right, so now we're there, and what we wanted is to get movement on the z-axis. So let me increase the speed again on the jogging. So let's do a move on the z. So you can see, moving the z. Oh, it gave me an error because I exceeded the, I probably exceeded, acknowledge error. You see. So let's make this slower. See how far I can go. 72 millimeters. Okay. Why 72? Configuration mode, kinematic. I have it set to 97. Let's see here. This is interesting. Let's move all of the axes to their 0 positions. 0, 0. Maybe someone that's watching this, I see some people are watching this live, maybe you have some ideas of what I'm doing wrong here. Why is the z-axis faulting at 71 instead of 97? Let's move all of the axes to 0. Okay, they're there. So 0, 0, 0. Now let's go back to jogging and move the z-axis only. Okay, it's moving. It's moving. You know what? You know what's the problem? That I configured this to be 97, but in reality, I don't think this is the case. I think that this axis has a smaller stroke. No, it doesn't. Maybe, yeah, maybe I have something else wrong. I bet what I have wrong is the, let me take a look at one setting here. I bet what I have wrong is probably the scaling. Yeah, so let's see. It says here that for every revolution, it's going to move 6 millimeters, right? So I'm actually glad that this came up because I can show you how to solve this. Part number for this is EGSC BSKF 32100AP. Okay, I'll show you how to fix this. Don't worry about it. Let's see. So let's fix these units in application. This is an EGSC. What I'm going to be using, this Festo software, which is pretty cool. It's called Quick Search Plus, and it helps you to quickly look for parts. So let me do that. EGSC 32, oh sorry, EGSC BS-KF-32-100, and then AP. Now this part number, just because I know the part number, I know that the AP means something, and that's what I'm going to show you. So if I go and open the data sheet for this, this is the device that I'm using for the z-axis. I want to see this. 8P means that for every revolution, it advances 8 millimeters. Okay? So let's minimize this. And this is exactly what I need to adjust here. Right now, what's happening is that for every time it rotates completely, like it does one full turn, it thinks it's advancing 6 millimeters. So that's why we're encountering that issue. So I'm going to change this to 8 millimeters. And now let's download this change. So this is one of those things that you got to be aware of. I guess maybe there's a thing to be mentioned there. This is where mechatronics I've been talking a lot about this online. You know, mechatronics is a really good discipline because now you can understand the mechanical concepts. Like, I didn't have to reach out to a mechanical engineer to explain this to me, like the pitch of the actuator. I know the basic stuff, you know, mechanical basic stuff. I'm not an expert mechanically, like I can't design a full machine, but at the very least I'm able to, you know, figure out some of these issues. All right, let's run the program again, and let's go back here. Configuration mode, we're gonna log in with the password. Log in, then if we have to load the parameter file, and then we go into kinematics, set to 97. Okay, now we're gonna do let's do that home again. I don't know how that's gonna work out, but let's see. Start, and let me just position myself here. Okay, you see how it moves? That's just because this is supposed to be fixed to a structure. There's like some foot mountings that go here in the profile, and then this is supposed to go down like with 4 screws attached to a structure. And I mean, I'm not building a machine right now. I just have this to show you what I'm doing. But that's how it's supposed to be mounted. All right, I'm back. So our homing procedure went well. Now let's try that again. Let's try the z-axis. Now it should let me go all the way to 97. Okay. Yes. Well, 96.9. Maybe I have something else wrong, but it's close enough for now. You know, just for now. Okay. So because I spent so much time on that, I'm going to show you some other things now. Some of these other modes. So PTP mode, that's basically point-to-point mode. And what you can do now is that you can specify a position on X, Y, and Z at the same time, and it's going to execute that position on all the axes together, right? So let's say, for example, on X I want 350, on Y I want 113, and on Z I want, I don't know, 22. So now what I need to do is I just need to hit start, and it'll go. You can see all of the axes moving at the same time. It does it. Did it. Okay, that's good. I can, of course, I can change the speed. You know, if I wanted to do double the speed and go back to 0 maybe here and leave this at 50 and do 90 here. Start. So now the 3 axes go at the same time. This is what we call like coordinated motion, right? It's gonna try to achieve the set point on the 3 axes at the same time. So it has to do some calculation so it achieves that position at the same time on the 3 axes. Okay, there's definitely more things here. One other thing that I like a lot about this web visualization is that you have this override. So like on CNC machines where you have, I think on most CNC machines or many CNC machines, you have this like wheel that you can use to excuse me, that you can use to adjust the speed on the fly. You can do that to here. So for instance, I'm gonna command it to another position, like almost full stroke, like 400, and then I don't know, 150, and leave it there at 90. That was kind of like at a higher speed. I'm gonna do a low speed at 50, and I'm gonna send it back to 0 on all of the axes, just to show you that override function. So I'm gonna set the override to, let's say, 25. And this is a percentage. I forgot to mention that. So 25%, and I'm gonna hit start. Oh, sorry, I left it on. When I hit start, it's gonna go at 25% of 50 millimeters per second. Okay, so let's do that. And once I do that, I'm gonna, on the fly, I'm gonna adjust the override. So let's do that. Start, And now I want you to see it's moving, and I can now play dynamically with this value. So this is perfect for debugging too. Like if you want to see what's happening on a movement or something, you can do that here. You can see now it reached 0, 0, 0. Awesome. So any questions, any comments? Do you guys have any questions on what I've done so far? I don't know if we have any programmers or controls guys on the live right now. You see that there are 10 people connected at this moment in time. So let me know if you have any questions. The other thing that I wanted to show you, and I don't know how much time I've been doing this already, but I don't want this to be too long. The other thing that I wanted to show you is how will this look like in programmatically in CODESYS. So let's take a look. Let's definitely take a look at that. So CODESYS, where is it? Right here. So in CODESYS, I remember that I mentioned to you that this is like a library, right? Like this is a library that you can download directly from the Festo website. I'm going to close all of this. And if you go into the POU section on the library, oh, Kevin, okay, can you show us the CNC editor? Yeah, that's a good point. I'll show you that. Ronnie, thanks for sharing. What is the CODESYS version? I'll get to your point, Kevin, in just a second. Let me show Ronnie the CODESYS version. Right now I'm running CODESYS version 3.5, Service Pack 12, Patch 6. Okay? That's the version that I'm running. Now, Kevin says, can you show us the CNC editor? Yeah, like that. CNC editor. So on CODESYS, there is a CNC editor where you can have DXF files. For example, this file, this is G-code right here in CODESYS. So you have G-code to perform this thing, right? Or this drawing, if you want to see it like that. Now, within CODESYS, there's an option to do DXF import. This is a big thing, and I've used it several times on different applications, and it saves a lot of time. Actually, maybe I should just pull up a. Let me see. Let's pull up a DXF file. DXF file test. I don't know. Let's see if we find something. On the DXF file test. I think I have something on my like this hello, for example. DXF file, yeah, hello, download. See if it goes through. 1 second, come on, you can do it. There it is. Save. And then I'm going to save it somewhere. Just going to save it there. Okay. And let's see if we can pull it up here. So I'm going to create a new CNC program. And I don't know, Kevin, if you wanted to go this deep, but we're already here, man. So let's do it. LinkedIn Live. Yeah. And oh, I need to, this naming is not right. I think I have to use underscores instead of spaces. So now let's do CNC and then import from DXF file. And let me look at that location of that file. There it is. That's the DXF file that I just found on the website, on the internet, the first one that came up. Now I can just do import. And this is the beauty of this. So imagine like a more complex DXF file. You can just import it directly here, and now you have the full G-code directly embedded in CODESYS. And we can see here there's a bunch, like these are a bunch of linear movements, G01, yeah. Just a bunch of linear movements like this. I don't remember how to zoom in here. Yeah, there we go. So even the E and the O looks like they are lines. And if I click on one portion, it's going to highlight which line is that within within that DXF file. So that's that. I got another. I think Kevin already got excited about, like, let's do it. Like, you want to execute this code now. Oh, sorry. Like, oh man, I'm showing all of you this thing, and I still have the hardware in front of you. But yeah, this is the drawing. Hello, right? And now from here, of course, there are some things that you will have to manually change. There's a comment from Alejandro. I'll get to it in just a second. There's a couple of things that you have to adjust. Like, for example, yes, this DXF file is just an XY. It's just in one plane, right? Like 2 axes moving. But remember that we have a Z axis. So if I wanted to, let's say, like if I had a routing bit on something, like I had a routing tool that I'm developing, or maybe just even a pencil or a pen, remember that that Z-axis is going to have to go down at one point. So the only thing that you will need to do here is you will need to add some lines for when is the Z-axis going to come down. So for example, it seems like this is my very first move. Before this move, I will want the Z-axis to be up, right? So here you would add, you know, like N00, 0, and then G 0, 0, and then you will do C. You want it to be up. So let's say that it's mounted vertically like this. You would do Z 0. So it's all the way up, right? And then after you move to, let's say, this first point, before you do this line, so after this line, so at this point, you want the Z-axis to come down. So then you will do Z, and depending on the height of what you're doing, you will do C25, for example. Now, the Z-axis will come down here, and then after this line, depending on how this thing is going, apparently all of this is continuous, but this line here seems to be where you would move your Z-axis again. So here, you would raise your Z-axis again and then lower it at the other point. So anyways, that's kind of like a summary. Alejandro Lopez says, can you show us how to communicate this with higher level PLCs like AB or Siemens or even Beckhoff Omron? Yeah, of course I can. Let's see here. So there is, we have this site set up. Let me just find it here. You have this site set up. This site set up where you can download the AOIs for other platforms. So for instance, here you can see for Ethernet IP applications where a higher order PLC acts as a host controlling up to 3 different kinematics. This is where you would use this file. Let me see what's in this file. No, that's not it. What am I missing here? Oh, this is the file. Sorry. So here, you would go into here, and now you can download this file. Within this file, you have the function blocks for Siemens and version 15. You have the function blocks or the AOIs for Rockwell. You can download it from here. You can even get the mapping, error codes, and everything from here. Let's see. So if I open one of these files, let me open one of these files to show you how it looks like. Yeah, so how the AOI looks like. Remember that the things that I was showing you earlier, this web visualization and everything is explained on this document, but I want to show you the AOI. So here's an example of the AOI for Rockwell. So with Ethernet IP, you will have this AOI, and within this AOI, remember the mode selector that I was showing you, and like like configuration mode and homing mode and point-to-point jogging. This is where you have that selector. So each of those modes has a number, and you will set the number, and then you will get feedback on, okay, what's the number that you selected, and so on. You also have some options here, like for example, the coordinates for X, Y, and Z axis. So you have the 3 coordinates here. You have a parameter for velocity here as well. You can do jogging, positive, negative on each of the axes on that kinematic, and so on. Maybe later on we can do an exercise with a Rockwell PLC. If anyone's interested, you can put it there on the chat, and later on we can do that, one of those examples. Okay, maybe let me put this link on the chat in case that anyone is interested in looking at this. So I'll put this here on the chat. There it is. So now you can find it there. You can take a look at it. All right. So where was I? Oh yeah, Kevin got me into this rabbit hole of the CNC configuration and everything. So we're here now. Okay, I think that's as far as I'm going to show. What I was going to show you is how this will look like programmatically if you were not using that, function block that I just showed. Well, let me close all of this. The way that this will look like is you have this GVL here, this global variable list, and you have, this is called in and out. Within this in and out, there's a structure here that will give you all of the data, and of course this is documented, but just explaining it now. You will have this structure for inputs and structure for outputs. These are of type global. These are of type global, and within this structure, you would be able to access all of these different variables. So what if I wanted to write a little sequence? Well, under main motion, I'm going to add a folder, and then I'm going to call this, I don't know, 01 underscore my program, like that. And then under these, folders or directories, just to keep things organized, I'm going to add an object, and this is going to be a POU. I'm going to do structured text, and I'm going to do my sequence, or my program. This is going to be a program, type program. This is not a function block, it's a program, and the implementation language is going to be structured text. I get a lot of, I've been seeing a lot of discussion online on LinkedIn and Reddit and some other places about, yeah, structured text is, that's the way to go. No, ladder is the way to go. No, this, no, that. I gotta say, my personal opinion is that each language has its place. You're not gonna program everything on structured text. I mean, that would be inefficient. There are some things where you might use like SFC or sequential function chart. Actually, SFC is pretty cool for like overall program management. So this one, SFC. You would also use in some other instances like a CFC or function block programming. Depends. Ladder has its place as well. Structured text has its place. I'm not a hater against any of those. I'm just gonna say my personal opinion is that they all have their place. Like for instance, today we're gonna use structured text. So, all right. Now, how do we even start this thing? I'm just gonna do this for a few more minutes. I don't know how long. Okay, I'm gonna do this probably for 10 minutes, and let's see how far we go, or we get. I'll keep monitoring this chat. All right. So the very first thing that we need is we're gonna need to monitor or follow a sequence, right? So I'm gonna declare something that I'm gonna call iStep auto, and I don't know, I'm gonna assign a number here, 10, just to declare the variable. And this is gonna be of type integer. That's why I call it I for integer. So there it is. And then we're gonna build. I just did that for to declare it, but we're gonna do a case statement. So case of iStep auto off, and then if iStep auto. Oh, if iStep auto it's equals to 10. Then do something, right? What am I missing here? Oh, build. Let's see. Oh, this is taking a while to build. Shouldn't click that build. So we're gonna start by saying we are going to start with number 10 for a sequence. I don't know why it was giving me that error. Okay. If iStep auto, then we got to do something. And if you remember what we did, oh, now we have some errors. Oh, I don't have a something here. I don't know. X light equals to true. Would this suffice? Var bool bio. Do I have some water here? Yeah, I do. Hopefully you cannot hear the music that I have running on the background, because I don't want this to get flagged for copyright or anything like that. Okay, if our I-step auto is equals to 10, then what we want to do is we want to check. You remember those variables that I showed you earlier, those structures? We want to check some of these variables. So we want to select the mode of operation. We want to set the mode of operation to something. And if we look at here, if we look at this, we have these different modes, right? So this is 0, 1, 2, 3, 4, 5, 6, and 7. And actually, hold on a second. Still watching the chat if you have any other questions. Oops. Okay. Okay, so first thing that we're going to do is do 1, which is going to take us to, actually, you know what? I'm just going to start with the mode that we're in right now. So for example, point to point. So 0, 0, 1, 2, 3, 4, 5. So mode 5. I'm not gonna do this whole thing. GST is STIN is mode 1. Ah, now I remember what I'm doing wrong. Yeah, of course, this is not like this. The case statement is like this. How come no one told me there in the chat? There we go. Now it's looking better. That's why it was telling me, like, what are you doing? Okay, so now here we're setting the mode to point. Then on I-step 20, what we need to check is if the mode actually did change. Emop display should be if this is equals to 5, then if this is equals to 5, actually I need to jump next case. Copy, paste this. We're gonna do 30 here. If it is 5, then it's gonna jump to 30, and then on 30 we're gonna assign the position where we wanna move to. STIN, and then let me remember what's the name of this thing. ST position point to point. I think it's this one. And then for X, we want, let's say 250. And then we're gonna do the same for Y. Write a position, right? So we wanna position for Y, and on Y have a shorter stroke, so I'm gonna do, I don't know, 80. And then on Z, I'm gonna do, what should we do? Let's do half, which would be 50. Then on we need to specify velocity as well. G underscore STIN dot ST. or isn't it? It's st. Yeah, velocity. And here we're going to set it to 150. What was I using for acceleration and deceleration? Does anyone remember? 1,000, so let's use the same. Or maybe vary it, you know, like, let's do 2,000. And let's make it decelerate slower. Decelerate, yeah, decelerate at 250. Now, after you do this, I want you to jump to the next step. I don't know if everyone is used to using these case statements. Okay, so after that, what do we want to do? We want to execute a move, right? We want to execute a move. So what we were going to do is, and actually if I look back at the visualization, there are some conditionals that I should probably add here. Maybe we'll add them here, like at 0. 0, we're going to say if, let's see, g st out dot x, no, gst out selected axis CNC status word. Okay, and then we want to make sure that its configuration was done. Of course, you will have more steps before this, but I'm just trying to simplify this. And oops, so you wanted to check if the configuration was done, and you wanted to check if, what else? You wanted to check if it's enabled, of course, X enabled, and you want to check if, what else? If it's homed, for instance, X home, then do something, right? And what we're going to do in this case is, I don't know if I'm the only one that usually uses tab for this, but I like how it organizes the indentations on the code. So what do we want it to do? We want it to go to the next step, which is going to be step 10, right? And before, yeah, here, I'm actually going to add a button. Did I add a button here earlier? No. Maybe I should leave this. I'm going to turn this light into a button. Okay, so if X button is true, then we want you to do what? We want you to st in we want you to start movement. Why not? Why not? It's going to be true. I mean, this is, we're all testing here, right? So nothing's going to happen. This is just to show something. And then after you set this to true, I want you to jump to the next step, which is going to be step 50. And then on step 50, I want to check if the movement was complete. So, well, actually I need to reset the start. So what I'm going to do is, if it's busy and it's moving, so if g underscore st out dot st, no, status word, what was the status word? stsw, yeah, stsw, and then x busy and g underscore st out dot status structure status word dot x is moving, then I want you to do something, right? So if both of these are true, then I want you to shut off the start or reset the start. So false. All right. Oh man, I wish that you guys could hear the songs, because I think we all work, or most of the people works with music, right? Like it's soothing, I guess. You get into a tune and you're like, oh yeah, jamming all the way through this little piece of code. If I do this, then I want to write the new step, which is going to be 60. Some people do, some people do, instead of the numbers, they just add it, like I step auto plus 1, or they do I step auto plus 10 in my case. I don't know. Like it's technically the same, but I like visualizing the numbers. I gotta say though, I don't do this every day. Like I'm not a programmer for every single, like I don't build machines or anything like that. So I wouldn't consider myself very proficient on this, as you can probably notice. But I really wonder, like maybe if someone can leave a comment on how do you do it? Do you usually use the I step auto plus 10, or you just use the numerical reference? Okay, so 60, then now we resetted that value. Now we want to see if the axis reached the position, and this is called motion complete. So now once we reach that 60, we're going to say if g underscore structure, or global structure out dot structure status word dot x motion complete, then what? That's strange. Why didn't it? And if, oops, and underscore if. I don't know why it didn't auto declare that end if. Am I missing something here? Maybe not. We can, toggle an output. Process done. This is true. Yes, we're missing a semicolon here. Okay. Why don't we give this a shot? I said I was gonna add a button here before. Yeah, there it is. So I wanted to stop here at 40, and then I'm gonna physically toggle this button, and then I wanted to start the sequence. So let's see if this works. And this is just a simple program to get this thing moving. Maybe what I'll do is I'll transition to this view so you can see. And because I didn't add all of the other steps for, enabling and all of that, I'm just going to enable it from here. And then let's go back to CODESYS here. Oh, you know what's going to be the problem here? Let's see if we have CODESYS users here on the live. Because I see some people are live or watching this. What's the problem? Why is my code like this and I'm not seeing live data? Any ideas? Let me see here. I'm gonna pause here because there's a delay on the stream. Any ideas why my program is not showing or displaying any live values? Oh wow, I need some WD-40 for this chair. Well, maybe no one has. Oh, I see a comment now. The task. Yes, Ronnie. Yes, I created a program, but I'm not adding it to my PLC tasks. So the PLC is like, I see that it exists, but you're not telling me to execute it, right? So I don't care about it. What I need to do is I need to log out and I need to add this program or call this program from my PLC task somewhere here, right? Or I could even call it from one of these programs as well. But no, I'm not going to do that. I'm just going to add it from here. So main motion, visual task. Let's add it on main motion. Program call, and then which is the program that we're gonna call? You remember the name, my program? Thank you, Ronnie. You're the man. Yeah, you knew what the issue was. It's good. That's good. Alrighty, let's re-download this login. I'm playing some, what am I playing right now? Playing some Plastilina Mosh. I don't know if anyone knows this group from Mexico. It's a nice rock group, Plastilina Mosh. And if you want to get a sense of what kind of music this is, this song that I'm it's Mr. P Mosh, the one that I'm listening to right now. Okay, so now the program is running. Thank you to Ronnie, because he knew what was going on. So now the program is running, but look at what happened here. Look at what happened here. The mode is in it commanded it to be 5. I wonder if my visualization is interfering with this. Let's close this and let's execute that again. 0. Nope. Oh. I know what's the problem. No one told me. When you assign, that's what happens when you don't read the user manuals and you write this code. You don't remember stuff. When you write this mode display, you also need to execute the change of mode. Almost forgot about that point. So G_st out. No, actually in. No, it's not here. What am I doing? It's here. Once you do this, G global structure in dot st control word dot x, and it's called something like setup mode. Yeah, setup mode. So this is basically kind of like an execute. So I'm gonna do this to true. Oh, I'm doing true. Yeah, and let's re-add this comment here. Okay, so now what happens here is I'm saying I want you to be mode 5. You know, like I'm preparing it, like I'm telling it, you're gonna be mode 5, okay? But then I'm telling it, now do it, like on this next line. Now do it, and now it should do it. Like now here, it should do it right here, and then it should change to the next step, and then it should display. So yeah, I was wrong there. It doesn't have anything to do with that. So let me open a new screen here, 192.168.4.2, and then go in here. All right, so we're in homing mode right now, and I want you to see this. So let's download this change, online change. There we go. So we're stuck at 20. Why? Because 10, the step 10 already went by, right? So it's like you didn't tell me to execute the mode. So let's change back to 0 the step, and then control F7. There we go. So now it's at 40, and it's waiting for us to trigger this button, right? So let's see if I go back here, and now it's giving me an error. Why? Why is it giving me an error? Let's see, diagnosis. Invalid mode of operation. Interesting. Let's see, what am I doing wrong? What am I doing wrong? For this is the point where, and I don't think that you guys are gonna know unless you're familiar with this library. But for this, what I can do is I can look at the user manual. Let's see, expert knowledge, collection of Festo positioning basic library application notes. And I'm actually glad that this came up, because that way I can show you where you can find the documentation for this library. So let's open this zip file. This is a zip file. And let's see, there's a bunch of application nodes here. It says mode of operation, enabling homing. Okay. See here. Let's see, maybe I'm using the wrong number. Homing mode, okay. Oh, I shouldn't be using, there's actually a okay, so maybe I don't have to use numbers. Maybe I can just use the what's already declared inside of the library. It's interesting. I don't remember this, but now it makes sense for sure. So here, where is it? Here. It says that there is a too many screens. F plus B E PTP. Okay. F plus B dot. What was it? PTP E. There you go. So config mode, configuration mode, and so on. So that way you don't have to call the numbers. Interesting. Totally forgot about this. Jogging mode, but we want the one that's called PTP mode. What's it called? ePTP. Okay, we're almost there. PTP mode. And now I could just compare this and say, are you in PTP or point-to-point mode, right? Do this. And let's try this again. It's interesting that it went through like, Let's do 0 again. Oh, it's 50, it's not 5. Yeah. Interesting. Okay. So let's clear the error on the visualization. Of course, you could clear this error directly on the... Yeah, it says that I'm commanding it to the incorrect mode. What am I missing here? GST... Okay, the change is checked by... okay, no. Okay. The operating mode is changed in the visualization by selecting the desired mode at the left-hand side. And I'm checking all of this without letting you guys see again. E mop display, F pos B E homing mode. Switching from homing mode to PTP manual is required. The mode is assigned to the E mop to this end, and the mode is activated by means of rising edge at the set OP mode, operating mode. Okay. So what is it that I'm doing wrong? ST in E mop. Okay. Set OP mode equal to true. Okay, and then emop display. Here's where they check. St out emop display equals F plus B EPTP manual. Oh, it's called mode now. Okay. So why is it that it's not letting me? It's not letting me. Get stuck here. So it says, if this is it because I didn't make this false? No, it's true now. Let's do another test. What I can do is I can send this to an unknown step, and then I can go into the visualization and acknowledge this error. Disable the system, acknowledge the error. It's not letting me select anything else. Could it be... Why is that? Diagnosis, invalid mop. Well, what if we force it? If we say, if we change this mode to, for example, config mode, like this, and then we do this true, does it take it? No. Huh. Maybe I did, maybe I sent it to a very unknown state where it doesn't know where it's at anymore. This is interesting. Okay, let's try this one more time. Configuration mode, password, login, load the parameter. Okay, and let's see what's the value here. It's in configuration mode. Okay, if I jump here, homing mode. Okay, it's taking it. PTP mode. Oh, this is fine. Okay. Okay, but I need to home it though. That's part of the conditionals I have there. Okay, did do it. So let's try this again. Huh, homing mop display. PTP mode. What if I change it to something different, like this, like that, and then I do a true? It does change, and it did change it here. Okay, if I change it to PTP mode now, like see, like this, and then I do a true. I wonder why it did that. I'll check that later. But I mean, I did manually what I was trying to do with the code, and it went through. So I don't know what I'm doing wrong. Maybe I need a slight delay between this becoming true, something like that. But anyways, now it's waiting for us to do the start button. Let me bring in this view. So let's force the start button, which is, this button is not part of the library. This is just a button that I added. So Control F7. And what happened? Step 50. It's not busy. Why it's not busy? It's giving me an error. Why is it giving me an error? Dynamic not valid. Okay. Why? Could it be that the acceleration is too high? Could it be? Could it be that the case? I don't think so, but let's see. Could it be that this only takes like 1,000? I don't remember what are the limitations here, but let's see. Let's do the button again. Oh, of course, I didn't clear the error. Gotta clear that error first, man. Go back to step 40 and let's acknowledge that error. It seems like it's still commanding it to start. Yeah, so let's acknowledge the error now. Why? 30? Huh. What am I doing here? What if I change this from here to 1,000 again? Okay, can I clear the error now? No. Dynamic PTP dynamic value not valid. What is it? What is not valid from here? 150. This is strange. I don't understand what's not valid. Any ideas from people here? Did you notice that I did anything crazy here that it's not right? Why? These values look fine to me, you know, 300. I wonder, let's see here. Doesn't even let me go there. Okay. Let's see. Does it want, these are real values. Okay. Let's try something. I'm curious about something. Let's restart these yeah. Let's restart and okay. And I'm also curious about what's happening on step 10 and step 10 and 20. Like what's the deal with that operation mode not changing? I'm curious about that. Okay. Try to figure it out. Oh man, I said I was gonna do like 20 more minutes of live. I got some other things to do. If it doesn't work this time, I'll do another live later. And I'll show this thing. Well, maybe not, because I need to ship this out. Okay. Okay. Did the home? Let's try something here. Oh, it went immediately to fault. Interesting. Okay. I'm gonna do the following. Oops, close this thing. Negative number for D cell. Could it be? Could that be? Does kind of make sense. Does make sense. Let's see. Okay. What was I doing? Log in. Nick, if this is true, man, I'm gonna owe you, I don't know, soda or a beer or something, because it does make sense. I wanna reset call. This is what happens when you don't do these things very often. You know, you lose it, and especially if you're not reading the user manuals. But this is the fun of it, right? Let's see. All right, let's test what Nick said about the negative value on this deceleration. It makes sense. Configuration. Let's load this. Let's enable the system and let's start homing. Don't mind the movement there. I know it doesn't look pretty, but it'll do for now. I think Nick got it. It did went to point mode. Like it just went through the 10 and 20, which we were struggling with before. I think that might be just an issue with the sequence. But now it's waiting for the button. So will it go? Oh man, Nick, are you still watching? Type something there on the chat so I can know if you're still watching. So I can know if you're still around. Type something on the chat. There's a delay here, so I'm waiting. Okay, Nick. You pointed out something really obvious, which wasn't obvious to me. Of course, I forgot. I owe you a drink of your choice, man. I owe you a drink of your choice. So mention something on the chat, whatever you want. Next time in England or in Great Britain, GB, I'll buy you something. Or whenever you're in Chicago or the US, you know, we'll hang out, man. I'll remember this for sure. But just type in whatever you want. I don't know what's your poison of choice or however you want to call it. That was cool. I you know, and that's exactly why I wanted to do this live, because I think it's pretty cool to do the interaction, you know, like to have this interaction. I'm not perfect, man. I'm gonna forget stuff, and I'm just doing this on the fly just to show you guys, just for fun. I had to shape this out actually, but yeah. So Nick, I owe you one. I think with that, I'm gonna finish this live now. Maybe next time we can do another one, and I can show you some other stuff. Maybe when I get this gantry back, maybe I can get another gantry here. I think I have two other gantries in here. But you know, or if you want to see something different, just shoot me a message. Shoot me a message. Like if you want to see, I have some other stuff like vision sensors, and I have a servo press too. Even servo drives, like if you want to see like synchronized motion, like syncing in or gearing out with servo drives, controlling a servo drive with Ethernet IP or Rockwell or Profinet on Siemens, EtherCAT on TwinCAT from Beckhoff. You can do that. Just you know, let me know what you want to see, and we'll put something together, and we'll all jump in and code it together. All right. I'm gonna start thinking about some sort of name for these live sessions, like let's code together, or let's automate together, something like that, something cheesy like that. All right, guys. Well, thank you all that watched this live. It took a while, but it was fun because we were able to troubleshoot something together. Remember, I guess my tip for the day is gonna be read the user manuals. I was trying to be clever here and just go by, but it's always good to have the user manuals handy. All right. Have a great rest of the day. Cheers to the people in Europe. I know it's kind of late there. Cheers to everyone in the Americas. I hope you enjoy the rest of your day. Bye-bye.